The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. This is Jake Reynolds speaking. I'm responsible for research at CISL, and I'm really pleased to welcome you all to this webinar on novel ways to produce sustainable chemicals and materials. I should just really mention that this webinar is part of a series of webinars, actually, which began before, at least in this part of the world, the summer break, which has featured the work of the Prince of Wales Global Sustainability Fellowship Programme. That's CISL's flagship independent research effort to explore the challenges faced by companies progressing the sustainability agenda. That programme's been going for a number of years now, and colleagues such as Polina Yaseneva, who I'm going to introduce in a second, is one of our Prince of Wales Fellows, and she'll be talking, as I say, about sustainable chemicals and materials. Previously in the series, we had contributions about air pollution in African cities and the role of the private sector in mobilizing around electric mobility to address that. We had a presentation and a webinar on food consumption within a British retail context. In particular, how do we encourage consumers to not only demand, but actually physically choose products with certain sustainability characteristics when they shop. And we had another webinar on the business benefits of living wages, really critical one, that to deal with the inequality crisis. And we looked at climate risks in aviation. So all of that came previously. We're now moving to the second round of webinars, and I'm really pleased to introduce Polina today, Polina Yaseneva, whose fellowship is focused on feasible pathways towards the utilization of the feedstocks for the paper and pulp industry in the production of sustainable chemicals and materials. And she's looked at this challenge through the lens of integrated life cycle assessment and the use of new tools for optimization. So a little bit about Polina's background. She is a sustainable chemist, and she obtained her PhD at Cardiff University. She then joined the University of Cambridge, in fact, the Department for Chemical Engineering and Biotechnology, where she was a research fellow jointly with the University of Warwick. And in these appointments, she worked on environmental assessment of novel chemical technologies, focusing on decision support, so quite practical considerations around decision support in the process industries. And she did that before joining as one of our Prince of Wales Fellows. Technical as this area is, and it's more technical, I can tell you, than some of the than some of my abilities allow. She has promised not to lose us in this webinar. So, Polina, we're counting on you to bring that area of knowledge into focus for us. And I should say that the participation in the webinar today has been really really excellent, and also really diverse, both geographically and in terms of the kinds of industries which have decided to log on today. So we're getting people from literally pretty much all regions of the world. We've got from the States, from China, from many different locations, obviously Europe and further afield, and also from a huge range of industries. There's and types of organization, from small companies to large companies. One's based in the finance industry, who I presume are thinking about the process of innovation and future value creation amongst companies, down to manufacturers and organizations that might actually be able to adopt some of the thinking that Polina has been developing. The webinar will be recorded for academic use, for our use here at CISL. I would encourage you, if I may, to use the facilities to submit your questions as Polina goes along. So it's really important that we hear from you as soon as Polina's finished. I will then turn to the questions which have been provided from the audience, and we'll try and go through as many of those as possible so that you have a chance to get some further insights from Polina based around your individual needs. So I'd like now to introduce or to welcome Polina. And Polina, you obviously have some slides for us. The idea is we're going to keep the presentation relatively brief. We do want to do justice to your work, but we also want time for questions afterwards. And with that, over to you.
Thanks so much, Jake, for the kind introduction, and good afternoon, everybody who joins us today. So I'm going to be talking about identification of pathways for sustainable chemicals and materials manufacturing. Manufacture of chemicals supports all areas of advanced technological society, and chemical substances provide vital services for our health, for our food security and daily life. The use of chemicals is ultimately linked to our society's modern lifestyle, and it has been steeply increasing over the past decades. So I wanted to start my presentation by showing you some numbers about chemistry in the environment around us. So it is known that over 95% of all manufactured goods are relying on chemistry. And there are 350,000 chemicals and mixtures of chemicals that have been registered for the official use across the world. So however large this number may seem to us, it's actually quite small when we think about the number of molecules that have been considered in R&Ds and by scientists, and it comes up to 32 million chemicals that are cited in scientific publications and patents. And even this number becomes really small when we turn to the numbers of predicted chemistry, which could potentially exist, and the latest number is 10 to the power of 60, which is only for the drug molecules. So we can see that the potential of use of chemistry and development of chemical manufacturing is actually unlimited. So what chemical manufacturing is actually? So it's a highly complex and largely linear supply chain in which we can observe some general features. The small number of commodity chemicals are usually produced through highly optimized processes with quite small waste stream and very large volumes of production. So this goes to the production of bulk chemicals and so-called intermediates, and it comes with increased function of chemicals and increase of structural diversity. And finally, we produce final products or consumer goods, which are usually presents as a mixture of molecules where one of the molecule which is delivers the target function, and other molecules are there for the support of this function. And this is, for example, in drug formulations or in paints or in different consumer domestic products. So along this supply chain, we can see increased functionality of products, increased diversity, and increased production of waste with decreased volume of production. So the manufacturing process of a single chemical is usually linear, and it consists of 4 main stages. First of all is preparation of feedstock, then manufacturing phase, then use phase of chemical, and the end of life. And throughout this life cycle of a chemical, resources and energy are consumed from the environment, and some emissions are released to the environment. It is known that today 90% of chemical industry uses fossil fuels as a feedstock for the production of its products. So, and global challenges incentive creates the need to switch for a circular manufacturing model. And these are climate change and serious problems like environmental pollution and human health. So let's look at what kind of impacts from chemicals and materials manufacturing are assessed today. So it is known that 6% of global CO2 emissions come from chemical industry. However, only 40% of these emissions come from direct operations and from power consumption, and 60% of them come from supply chain, also called Scope 3 emissions. So that makes tracking of impacts from chemical production very complicated. So biodiversity loss from chemical production and use is not really addressed properly due to the lack of robust metrics. So chemical pollution and its effect on the human health are not addressed properly, as rates of production of chemicals and release outstrip capacity for assessment and monitoring. So, for example, out of these 350,000 chemicals which we are talking about, 1/5 of chemicals remains unknown due to the confidentiality. So we don't even know what is being released to the environment. So we really want to switch to circular and sustainable chemicals manufacturing. And what would it mean for us? So the ideal sustainable circular manufacturing process design would take into consideration production of a material that fulfills current material function and possess proper recycling or utilization strategies at the end of the life of the chemical, and is being produced from sustainable renewable feedstocks rather than petrochemicals. So transition to the circular model would imply massive technological change in the production, and I'm going to explain why. So because of the use of new feedstock, we would have to develop completely new chemistry that never really existed before. Then we would need to develop new technologies for this new chemistry. We would want to integrate these new technologies with existing oil manufacturing, which is huge. And finally, if we use novel feedstocks which are located in different geographies, we would have to develop new business models and supply chains for chemical manufacturing. So chemical production systems are really complex and with often multiple options for production of the same molecule. So for example, it could be produced by the use of different feedstocks, or it could be produced via different production pathways. And the aim of chemical manufacturing transition is to identify the locally optimal sustainable production of molecules. How do we actually do it? We use life cycle analysis as the most comprehensive tool to assess production system, environmental and economic sustainability. And LCA relies on international standards, and it measures environmental impacts of products or services throughout their entire life cycle. The use of LCA-based methods is driven by developing policies and sustainability targets. So, for example, in the European Green Deal, they explicitly mention the use of LCA in quite a few packages. So some of the biodiversity strategy, for example, circular economy action plan, strategy for sustainable chemicals, and achieving climate neutrality as well. So life cycle assessment is a basis for product environmental footprint methodology and digital product passport for the assessment of products' environmental sustainability. So assessing the complete life cycle of chemicals and materials based on transparent, standardized, and accessible scientific methodologies will become a major foundation for gaining trust of the public and enabling evidence-based policies. So let's talk a little bit about scope of LCA in chemicals manufacturing particularly. So it closely relates to the technology readiness level scale. So technology usually starts from developing a concept and then it goes to the lab scale and finally is developed at the large scale. So assessment of new technologies at the early stage of production or process development at TRLs 4 to 5, for example, can be used to identify hotspots in process and improvement at the stage of development. And when we're dealing with assessment of technologically more advanced processes in the presence of more data, we could do scenario generation for potential demand. And this might involve estimating which current process the new process might replace and to what extent and with what environmental benefits. So to obtain robust and reliable predictions, one needs to have a large amount of process data information across the entire existing or potential manufacturing process and supply chain. And this brings us to the main challenges of LCA in existing and emerging chemicals manufacturing. So first of them is data availability and transparency. Then harmonization of LCA approaches and resource intensity of LCA. I will talk a little bit more about challenges with data availability, where they come from and what kind of problems we face. So on company level, there could be a lack of consistency in data collection for existing processes. And this happens because the processes, chemical production processes are complex and not always properly monitored or have been monitored because nobody ever needed this data before. So the second thing is confidentiality of technological information. So basically when data does exist, it could not be disclosed, quite often could not be disclosed due to confidentiality of technological information, and this happens due to competitiveness of technologies. And finally, for emergent processes, data needs to be modeled using different comprehensive modeling tools. So, for example, today in the largest LCA database, there are 1,900 data sets for different chemicals. So it's not even 1% of the chemicals that are being used today in the environment. So it just gives you an idea of the scope for the development of models and data for the assessment. So luckily, digitalization will help us with overcoming of these data challenges. So on company level, for example, we could be creating digital twins of production processes and digital representations of products as prerequisites for virtualization of supply chain. And this could help with the cost optimization and tracking and evaluation of environmental impacts. So on data exchange level, digitalization can help with development and use of safe and transparent data sharing infrastructure. And finally, for the prediction, artificial intelligence could be used for search for more sustainable and safe chemistries and manufacturing, covering potential environmental impacts comprehensively that is lacking today. And I will be talking a little bit more about examples of what kind of things are started being predicted for chemicals manufacturing. So, for example, machine learning and AI-supported tools could be used for predictions of molecular properties, such as thermodynamic properties or toxicity or biodegradability. So predicted properties can be used for the assessment of impacts of chemicals and materials on human health and on natural environment that are largely lacking today. So people at MIT started already doing the prediction of some of the properties of chemicals. So another thing that is very important and that could be predicted with digital tools is prediction of new molecules and materials with specific desired properties. It could be, for example, new drugs with new properties. So for most practical applications, discovery of new molecules and materials has been dependent largely on serendipity. And this largely limits the potential to find the best solutions for specific applications that are environmentally beneficial and safe. And finally, we could use digital tools for the prediction of chemical reactions and manufacturing processes and their environmental impacts. So there are many ways to manufacture a specific chemical, and prediction tools are aimed at finding sustainable and practical processes. And AI is expected to replace highly expensive and complex LCA with rapid prediction models. So here there's just a couple of examples of such attempts from the University of Aachen and the University of Santa Barbara in States. So in the conclusion, I'd like to say that systemic innovation is required to facilitate transition to more sustainable chemicals manufacturing, and it is clear that digitalization needs to become an important driver to overcome data challenges. Digitalization will drive innovation through the increased uptake and systemic adoption of digital tools to optimize management of chemicals life cycle. And finally, digitalization in chemistry will enable development of more flexible data exchange models, more transparent international and cross-sectoral chemical information transfer, and the chemistries that are both safe and sustainable by design. Thank you very much for your attention. That's all for me today.
Lovely. Thank you very much, Polina. Really, really helpful. And thanks for the extra effort indeed to bring it down to our level. I'm sure there are some highly qualified chemists on the call too who would have understood that in even more depth. But I appreciate the efforts you took there. The first thing I want to do is just mention that we have recently at CISL produced a report which ties into something that Polina said, which is the European policy around circular economy. In fact, the report which you can Google is called Digital Product Passport, the ticket to achieving a climate neutral and circular European economy, ? Which had a look at that whole area of digital product information and how that can be made more consistent and to enhance the traceability of products and what they're built from and some of those issues which actually at one level are quite shocking, Polina, the fact that we have 32 million chemicals, 350,000 only are registered, and I believe you said of those 350,000 registered chemicals, 70,000 are kind of undisclosed, undescribed because of intellectual property. So a total of less than 1% of those chemicals actually properly thought through from an LCA perspective. At one level, Polina, that's that's sort of, I know it probably doesn't feel like this in the industry, but that feels a little bit like the Wild West in terms of chemicals potentially being released into the environment with undisclosed properties. That sounds quite frightening. And so I think the importance of innovation here and perhaps the digitization is certainly seems to be a very valuable step to achieving more disclosure and more comparability and understanding some of the impacts which those chemicals might be having. So thanks for raising that with us. First question I may have, just a couple of clarifications, which and please others do keep contributing your questions to us so that we can pose those to Polina too. Just a sort of a starter one really, what would really constitute good practice, or perhaps even best practice, for a chemicals manufacturer in this area? Are there sort of simple things, or is it a question of digitization? Is it a question of a more kind of responsible strategy? What would be good practice from a chemicals manufacturer, and perhaps also from a major user of chemicals? How can they kind of become part of this innovation which you've described today?
Yeah, thanks, Jake. Well, I think it's on an organizational level, so there should be transformation, really significant one on organizational level. So probably chemicals or chemicals using companies, they should start from trying to digitalize their production and try to track flows, whatever they use, and try to understand their supply chain. It's quite a complex process, and it's been done discreetly, I would say at the moment. But some large chemical companies like BASF, they for sure doing it on a very advanced level. So they try to measure LC of every chemical they produce.
Polina, is that insight which they're generating, so BASF, is that shared for the benefit of other companies working in the same area? Is there a sort of way that that knowledge can be made available consistently across the industry, or is this sort of kept very close within each individual company?
Well, for sure, it's for the understanding of products' impacts, and this is for both for their partners and for their consumers as well.
Yeah. If I may, on a clarification, what do you actually mean by locally optimal sustainable solutions? It seemed to be quite a pivotal phrase in your presentation, but I wasn't sure I quite understood what you exactly meant.
Well, yes. So technologies should comply with planetary boundaries, but they also would have to satisfy local conditions of resources, of feedstocks, and energy, for example, biodiversity. So this solution could be optimal to a particular geography, basically. So that's what it means.
I see. So that sounds like you're getting into the kind of global, local, sometimes dilemma actually in sustainability strategy, that even if, for example, biodiversity, a species or a habitat might be quite abundant, well, it can work both ways. Abundant locally, it might actually be extremely rare on a global level or a larger scale, and vice versa. Something which is being eradicated at a global level might still remain locally abundant, or the other way around. So you're saying with, I suppose, unlike the climate agenda specifically, which is more of a kind of global debate, the key is here to design feedstock strategies and other strategies, local pollution strategies, which actually understand properly the local ecology. Is that broadly what you mean by locally optimal?
For sure, but I think this applies to climate change as well. So, for example, different energy mixes in different countries would give you a different impact from the same production pathway, for example. And
you get that through the LCA process?
You can, yes, you can measure it through LCA.
I was intrigued that you said that AI and neural networks, I think one of your papers referring to specifically, could speed up that process. I think it wouldn't be impolite of me to say that it could hardly be slowed down, could it? Because the the process is really complicated. And I've seen LCA studies which are 1,000 pages of technical documentation, which at one level doesn't surprise me that so few chemicals have been properly unraveled because of the effort required. Can we really look forward to massive efficiency and massive speeding up of really complicated processes like that through AI? Is that practical, do you think?
Well, from my point of view, it's the only way forward because we cannot keep doing it manually.
Yeah, okay. So moving on, we have a few audience questions. Are there any specific prediction tools which you can recommend and that exist in the marketplace already?
For the chemicals, so yes, I've put one. It's called the Click tool from Santa Barbara, which helps to predict environmental impacts and I believe human health impacts as well for the emerging chemical production technologies.
And this is AI based, is it?
Yes.
Okay. Another question I've got here, and thanks very much for those of you who've been submitting them. Are there business cases available which could be read and understood in more detail to see how, presented with this innovation challenge, how companies are actually making progress in practice?
Well, there's, as I said, BASF, I think, is quite successful in doing all of this, and they probably have something on their websites about this, and they definitely do public lectures, university lectures about how they adjust or restructure their business so that they meet sustainability targets in their product.
Yeah, I mean, I recall in the past, going back a decade or two, thinking about sustainable business in other contexts. At the outset, there used to be 2 or 3 companies which everybody pointed to, particularly from business schools and so forth, as the leading examples. But somehow that kind of implied that very few other companies were doing it, and it was just the leaders. I'm sure that's not quite the case. So it seems to me that a sort of broader base of case studies and approaches, what's working, what isn't working, why, all of these questions would be extremely helpful for those practitioners who are trying to crack on and push this area, and also for the finance institutions which are thinking, what would constitute good practice? How do I understand whether a company is actually on the right journey here, or worst case would be greenwash? But you're not aware of any particular kind of resources which might help there on a broader level than individual companies?
Well, there is actually IDMT Center at University of Cambridge in the Department of Chemistry, and they help companies to understand how to digitalize their processes and their operations. And so I'm sure there are centers like this.
We could maybe follow up with a link with colleagues who are interested to approach them. Here's another question, which is sort of firstly, I'll read it, quite eye-opening and concerning at the same time to understand the magnitude of the change that's required. But can you elaborate a bit more about the digital twin as a solution to the current situation?
So basically, yes, and I think the center in the Department of Chemistry, that what they help people to do is to understand how their flows within the company can be tracked, and how digital representation of these flows can be made. I'm not sure what exactly the asking person want me to elaborate on.
Well, it's just that I suppose it's the potential for digital twins to be to make a contribution to understanding?
Well, I think the potential is really big, but the problem actually for chemical industry is the lack of experts who would be understanding chemical processes and digitalization at the same time, and that's one of the limitations, I think, for the application in chemistry. So I think digitalization was quite successfully being applied in other industries, but chemistry is, because it's so complicated, it creates some limitations.
Back to Europe, how would you advise the handling of LCA requests at the current time when the European Commission is still working on their harmonization? I suppose that's a question which you could apply to many areas of policy which are, I suppose, rather late in the day, understanding the challenge and then working fast to find solutions. But you know, today we don't necessarily have all of the parts of the jigsaw neatly laid out in front of us. So are there sort of general principles which can be applied now ahead of European Commission kind of catching up or providing guidance?
Well, they actually, I think they're leaders in providing guidance, and the environmental footprint methodologies that I mentioned, it could be used if you want to do the assessment of your products or materials. And it's quite straight. It's complex, but it gives you a certain guidance on how to do the assessment.
Okay, good. That seems more positive. Thank you. Do you have any view on the commitments of chemical companies to achieve net zero? So more oriented to the climate agenda by, you know, for example, 2050. Is it? The question goes on. Is it likely? How likely is it that chemicals manufacturing companies can actually achieve this? You know, you've mentioned that they're 90% fossil based. Well, what are the barriers to achieving net zero in a typical large chemical company?
Well, I would say that it's energy transition is the main barrier or the main driver for becoming net zero, because there's not so much CO2 emissions that are produced in operations, but a lot of it comes from the use of energy for chemical processes. And there are different solutions that are being developed at the moment. I guess the achievement of target really depends on the development of these technologies and application.
Yes, so you'd point more towards the energy consumption than you would the feedstocks in terms of the net zero plan?
Well, because yes, the CO2 emissions, most of them come from the use of energy in all chemical processes, including petrochemical feedstocks.
Yeah. Specific question here about something called the EcoInvent database. There's somebody who joined late, and I apologize for joining a bit late. Did you mention the status of emission factors for chemicals? They know of the EcoInvent database and a study from the European Commission. But is there a need for a new, better database of emission factors?
It's not complete for sure, because as even very few chemicals are actually described in the database. And I think it's been constantly developed for the emission factors. I'm not sure what kind of impacts you mean, but there's no metrics for biodiversity, for example, and we need to develop it.
Okay, so better on the climate side, or the emission side at least, and far less available on that. Unfortunately, Polina, is a rather typical story that, you know, and in fact there are commentators at the moment that are worried that much of the sustainable business debate is focused on climate. Of course, it's a massive problem, but really we need to become more familiar with the full spectrum of environmental and indeed social issues around for example, chemical production or other kind of businesses, rather than just focus on the climate, however important that is. And I suspect that your feeling is that that is the case in the chemicals industry too.
Well, there's a term of chemical pollution crisis that is not so well known among larger sustainability challenges, but it is going on, and yes, people know about this.
Yeah. Here's another question. Do technologies already exist which enable commercial chemicals manufacturing to use alternative feedstocks, so moving away from fossil fuels as the feedstock? And I guess I should mention, I was going to express our appreciation to SAPI, the company that funded this work originally on an independent basis at Cambridge, who of course is a paper and pulp manufacturer. And I imagine one of the interests which they had, which I think is as far as I understand quite realistic, is to begin looking at non-fossil feedstocks such as paper and pulp as the solution to that. It comes with some of its own challenges, but as an alternative to the 90% focus on fossil fuels as feedstock. So what technologies are there, and how is that moving? How rapidly is that moving to switch away from to more renewable feedstocks for the chemicals industry?
Well, there are definitely some technology present already. I won't lie about the number, but I think it's around 1% or few percent of chemicals are now produced from bio-based feedstocks, for example. And they do exist, but it's again, it's limited due to uncertain impacts from these technologies, which are hard to measure due to competitiveness, due to very low exchange of information. So different producers of technologies, they don't talk to each other because they're afraid of competition. So it's, but it's been done, and hopefully it will move forward. I think the problem is the investment in new technologies and critical thinking of investors about technologies due to the lack of information of the actual sustainability of these new solutions.
Okay, so a number of factors at work there. One is finance, which may be of interest to some colleagues on the call. Potential lack of investment in new pathways based around alternative feedstocks. And of course, the policy framework, which is, at least in Europe, is strengthening, and I'm sure other parts of the world are moving in the same direction. But perhaps policy is also one of those well, potential opportunity, but often a constraint. What would you say there was a kind of vested interests problem here too? It's quite a sensitive topic, but would you say that it's convenient for the chemicals industry to remain focused on more conventional feedstocks as opposed to experimenting or innovating in new ones?
Well, I wouldn't say so. So as I see quite a lot of enthusiasm in chemical companies to switch to more sustainable feedstocks, so and they try to make efforts to do this. Sure. And there is an understanding that we have to do it, otherwise it's yeah. Not very
because
good.
of regulatory push?
I think it's mainly because of demand of sustainable products. So companies are interested to satisfy their consumers.
Okay, so there's a market push there as well as a regulatory push. That sounds positive if that's the case, and hopefully a financial push too, coming from the investment community. Those of you who are in asset management or investment, seriously something to encourage amongst the investee company base. Yeah. Do you have any views about where in the supply chain or where in the process of obtaining chemicals as users we would be best advised to focus our information requests. So, for example, there's a question here which is asking about importation. Is the sort of process of purchasing chemical products the point when, as a user, one might demand to know the life cycle, or is this something which ought to be pre-set in the public domain through another process? I'm just building on your point there about the market push. How do users increase their influence over producers of chemicals so that they can enhance that market signal?
I know that for some of the new sustainable developed products, there are requests from particular interested businesses to buy it as a feedstock. They would request results of LCA, and that's how it's done. I guess if there is a potential buyer in large amounts for the product. In terms of individual consumers, it's more about behavior change and how people change their behavior and how they care about what they use and how it's produced. It's more complicated.
Okay, well, thank you. Just a couple more. If anyone does have a further question, please submit it. I've got a couple more here, and then I think we'll attempt to wrap up. But there is still time to pose another question if you wish. And lo and behold, in front of me, there's another question. Thank you. This question is about how the industry sort of standardizes and supports progress itself. So let me read it. In the chemical industry, there's no standardization of targets and reference points in reporting and transformation of companies. In other words, each does that on its own. Do you expect, Polina, that certain KPIs will become standardized and enforced by the industry? I mean, this is sort of, I guess, stewardship codes or agreed operating principles to ensure that the transformation we're talking about here is real and to avoid the potential for greenwash, which of course is always there. So how much industry action or industry coordination around this? Because previously you mentioned that there's a degree of competition here, which is sometimes prevents information exchange, which would seem to act against industry sorting itself out. So how do you see that?
There are different initiatives, and the main one, I think it's called Pathfinder, where industries cooperate on the finding a solution how to share their climate change impact, and this involves chemical industries as well. And this could be a way forward for the starting of understanding of what kind of impacts are produced. And they're trying to build a platform where the data is shared securely and it's amended so that it's provable that what is shared, it is what it is.
Sounds like that work has some way to go, but is potentially a very important start. Final major question here from the participants, and it's a really interesting one about the way that we can ramp up, speed up the transition to more sustainable feedstocks. And I think by that we're talking about biosourced. Of course, it's not sustainable by definition, but can be with proper management. So the impacts of the biosourced materials are not clear yet, as the information is limited, as you've mentioned, Polina. In addition, biosourced materials and recycled materials are available only in very small volumes at the moment. So how can the industry resolve that? How can it speed up the transition to those forms of feedstocks on a larger scale to compete with, and then potentially in the future to displace fossil-based materials?
Sure. Yeah, I think we've discussed it earlier. It's through the investment mainly. I think that would speed up development of technologies quite.
Yeah, but I mean, literally is the land there? Are the bio resources there, or do we have to think differently about land use or how we produce them?
Well, there are different feedstocks. For example, we can use CO2 as a feedstock for the production of molecules, and that's one of the really large topics now. And CO2 can be captured and used for the production of chemicals without use of any land or anything. That's
okay.
Another very promising feedstock for chemicals.
Yeah, sorry for foretelling that was the last question, because we just had one on here, and I promise this is the last one.
No worries.
It is that you've been answering a lot of questions. If the majority of the carbon footprint of this industry is in the use of energy and feedstocks, how will the digitization of the chemical development process produce a sustainable pathway? That's interesting, because even if you digitize, you've still got your carbon footprint in the energy and the feedstock. So where's the benefit?
It's the first step in understanding of benchmarks of the production. So we ultimately want to tie all our impacts to planetary boundaries. But to understand this, we need to know what are the benchmarks and what kind of impacts the current production makes, so that we can establish whether the new processes are better or worse.
Okay, thank you, Polina. I think we'll probably leave it there. There's a final question, which isn't really a question, but it's a request, and that is and hopefully, Polina, an easy one for you to answer. Is there a written academic paper which we can read for more details on Dr. Polina's presentation today? So where would you say we go for further information?
Of course, it's been cited in the presentation
Okay.
on the. I'm not sure what's the slide number, but with a picture of the whole system, and it's paper in journal called Chem.
Chem. Okay. Well, we'll make sure when we follow up with the participants that that's drawn to their attention. So with that, I think we should draw matters to a close. Always good, I feel, to end these webinars with perhaps just a few minutes before the ultimate closing time, just in case people need to get refreshments or do something else. So I hope that's okay with everyone. We'll reclaim 2 or 3 minutes back in our lives. Thank you ever so much for joining this. I should say a big thank you to SAPI, the paper and pulp company, for supporting the work in the first place, because without those corporate gifts, we wouldn't be able to undertake the work, and that's really very welcome indeed. I'd also like to say thank you to Rebecca Dogweiler and Jana Hoon, who've been very instrumental in setting up both the previous webinar series and this one. Done a fantastic job in organising it and in generating with other CISL colleagues the quite significant participation that we have today. So that's really, really welcome. Thank you very much. Obviously like to thank you, Polina, for a great presentation and answering probably about 20 questions, which may be more than you were expecting, but you still seem to be alive and happy. And thank you very much for all of you who've joined today from the audience. Really great that you've been involved. Next week, we're going to be looking at China's Belt and Road Initiative and the social and environmental justice implications of some of the world's largest infrastructure developments, including ports and railways and major investments which are choreographed in part by the Chinese government as part of its Belt and Road Initiative, the world's largest infrastructure investment. So that'll be with Elia Apostolopoulou, who is like Polina, one of our Prince of Wales fellows, and she is just completing her work with support from the Equalities Foundation in Hong Kong. So with that, thank you all again very, very much indeed, and hopefully see you next time. Bye-bye.
Thanks so much. Bye.